Order. Here we go. The lesson's recording, and we're going to be doing Law of Cosines. Now, did we cover Law of Sines last time? And do you remember the Law of Sines had that weird thing called the ambiguous case? That only sometimes that matters? Well, the good news about this lesson is that the Law of Cosines doesn't have that. The Law of Cosines, when it applies, is always straightforward. You just work it, you get your answers, you're done. I need to give you the formulas, though. There are 6 of them. Here we go. Formulas for the Law of Cosines. Bam, there's the first 3. First 3 formulas for the Law of Cosines. And I might mention that these formulas are used in a side angle side setup. If you have an SAS setup, that's Law of Sines. That's those 3 formulas. All right, here comes the other 3. And notice that I wasn't looking at a formula sheet when I wrote those down. Yes, I have those memorized. Not that I wanted to. It's like the movie Groundhog Day. If you live the same day over and over and over again, eventually you just know everything about it. And these 3 formulas are used if you have a side-side-side setup. If you have all 3 sides, you can use one of those formulas. And the first example we're going to look at is number 9. And before I do that, I need to make sure everybody's ready to go. Anybody still writing those down? Side angle side. Not to be confused with angle side side. Anybody get that one? ASS? Okay. Now this does have to be an angle between the 2 sides. Yeah. What does the other one stand for? Side, side, side? SSS, side, side, side? And side angle side. Yeah.
That's only the ones next to each other. So you have a side and an angle and a side.
Right. Right. 2 sides and the included angle. That's a SAS. And I'm going to make sure that you know how to tell that it's SAS, okay? I got a little secret. Now, is everybody ready to start number 9, or anybody still writing those formulas down? Anybody still writing? Okay, here we go. Number 9. And we've got 45 and 2 and 4. Now the problem says to solve the triangle. And if you remember from last time when we did Law of Sines, If it says solve the triangle, that means that you look for all of the missing pieces. Now, normally they're going to give you 3 pieces and you have to find 3 pieces. Y'all do know there's 6 total pieces, right? 3 angles, 3 sides. And I also want you to notice that they gave me a picture, but they didn't label anything. So do y'all want to go through and label A, B, C? Okay, and it doesn't matter where you put them. So what do you want this top angle to be? Okay, we'll make him A. And then what about the 45? B. And then you don't have a choice, that's got to be C. Now, did y'all know that the little letters go across from the big letters? So then that makes 4 little a, and 2 has to be little c. Does everybody see that? See. Haha. Now, if you take an inventory of what we're given, do you see that we're given an A, B, and a C? That's a guaranteed side angle side. If you're given an A, B, and a C, if all 3 letters are different, you feel me? And one of them's an angle, that's going to be a guaranteed side angle side. So what side do I not know? Little b. And so that means we want to use this formula right here because it's really close to having little b by itself. Does everybody see how to tell which formula to use? It's a side angle side and we're looking for little b. So let's do plug and play. All right, that's going to be a squared plus c squared minus 2 times a times c times cosine of 45. Everybody see what happened? I took the formula and I just did plug and play. I plugged in the numbers everywhere they went for A, C, and big B. And then it's time to push the buttons. And you can actually put all of this in your calculator all at one time and hit equals. It is possible with your scientific or graphing calculator to do that calculation all at one time. Hey, but what mode do you need to be in? Got to be in degree mode. And that's going to be something like, I don't know, 16, 17, 18, 15, something like that. No? Anybody get an answer yet?
I'm in degree mode. I have 20 minus 8 square root of 2.
Can you hit the SD button?
I got negative 70.5.
I'm sorry?
I got negative 70.5.
It can't be negative.
That's what happens when you press the S.
Where do you want the decimal place?
Maybe 2 decimal places?
Okay, then,
That's what you get when you press the S.
It gives you a negative?
Yeah.
Okay, something bad happened.
I got it.
Oh, I put this. Actually, that's what it is.
Okay.
One too many fours, huh?
So did I got 4 from that.
Press the SD.
Eight point six eight six. 8.686.
Yeah, I mean. Yep.
Everybody?
Yeah. Put it on action.
8.686.
Next thing I both got 2 square root of 2.
Well, where's your button pushes? Okay, let's see what you did here.
That's what.
How'd you get 20? Oh, 16 plus 4 is 20. 4 times 2
I
is
know what
8
we're
plus
calling.
2. 2 and 8 is 16. Did you do 20 minus 16 is 4 and then times it?
That's what I do.
You violated the order of operations. You did subtraction before multiplication. I'm going to have to write you a ticket for breaking the laws of math. That's why I want you to do it all at one time and not piece by piece. So what is it? 8.686? Whatever. It doesn't matter. And then what do I need to do to that? What do I need to do to get rid of the squared? I got to square root that. Now I want that to the nearest tenth. What is the square root of that decimal number to the nearest tenth? 2.9. Oh, there you go. Pull out the big guns. Everybody needs to break out the calculator. Now, does anybody have any questions so far? It's okay if you want to ask me a question. I'm not done. I just want to know, are there any questions before I move on? All the missing pieces. So I'm going to have to find little b, big A, and big C. I'm going to have to find all three of those missing pieces. We can. Or we could go back to using law of sines now. Because now notice I have an angle in the side across from it, and that's what is necessary for law of sines to work. So can you tell me which of these two angles would be the smallest? Would angle C be smaller than A or vice versa? C has to be smaller than A. Do y'all see why? Because his side is smaller than A. The smaller the side, the smaller the angle. So which angle is smaller, A or C? And so we're going to use the law of sines to find angle C. And I'm going to show you that the law of sines can be effective here, okay? So what's going to go in the first fraction? Sine of, okay, good, 45 over 2.9. Sine of C over 2. Y'all haven't forgotten how to set up the law of sines, have you? Remember that numbers that are across from each other have to go in the same fraction. And now that I have this set up, I'm going to cross multiply. 2.9 sine C, 2 sine 45, and divide both sides by 2.9. And that's going to be 0 point something. And as soon as somebody has that decimal, I'd like to have it to 4 places. 0.4877. And I'm going to wait for verification. Okay, verified. And then we're going to do the inverse sign of that. What is the inverse sign of that number? I didn't hear that. 29.2. Yeah, okay, so since that's an angle, normally we would round that to the nearest whole number. We're going to take 29.2 though, this time. 29.2. Okay, so I've only got one piece left to find. Do you want to use the law of sines or the law of cosines? Or neither? Neither? You just want to make them add up to 180? Yeah, good call. So what is 45 plus 29.2 subtracted from 180? How much does angle A have to be? Okay, one something. 105.8? Agreed? Don't forget, all three angles have to add up to make 180. And if they don't add up to 180, you screwed something up. Anybody have any questions? Okay, so if I wanted to check this to make sure that my math is correct, I'm going to show you what I would do to check it, okay? Not that you have to do the calculation I'm about to do, but you can if you want to. I would find angle A now using the law of cosines and see if I get the same answer. So now we're going to go to this formula right here, and we're going to plug in for A, B, and C and calculate angle A. All right, so what is B? 2.9 squared plus 2 squared minus 4 squared all over 2 times 2.9 times 2. And I really would appreciate it if somebody would work that out as a decimal. And remember, if you're doing that all at one time, you may need to use parentheses around the top and the bottom, especially if you're using a graphing calculator. And I bet $1 to a donut that it's negative point something. What is it? Negative 0 point what? What? And then what is the inverse cosine of that? 71.9. That's a little bit off. Did you do inverse sine or cosine?
Inverse cosine.
Sine or cosine?
Cosine.
Of negative 0 point. Okay. Oh, it's 108. That's a little bit off too. Because we got 105.8 when we did it. You got what? 108. That's a little bit off. It should be closer than that. Nope. Oh man, I wish I had my calculator so I could check. So, has anybody added all of those angles to make sure they add up to make 180? Just to make sure? They do? Hmm. Y'all don't understand why I'm perplexed, do you? It should be closer than that. 108, this number should be closer to that, I think. Because I would say, well, it's just round off error, but that's a lot of error. Yeah, see, this is rounded, right? The 8.686, that's rounded, and then this is even rounded further. Is that really 2.9 rounded?
If 2.9 is changed to a 3, it gives you 104.9, which is closer to the 105.
If this is changed to 3, that would even be more error. If I round that to 3, that's even more round off error.
It gives you a closer number to A.
Oh, does it?
C too. We also rounded C too.
It would round to 105.
Yeah, so I'm not happy with that. But at least it's close. I mean, it's somewhat close, right? Yeah, so we're going to call that good and move on. Yeah, close enough. Close enough. We're going to chalk it up to round off error. And we're going to move on. Next problem. Number 15. Number 15. And again, they give me a picture, but they don't label anything. So I'd kind of like to label the angles at least. What should we call the top angle? You want to call it A? What about the bottom left? And does it really matter? No, absolutely not. Doesn't matter at all. But now once you get the big letters in place, then the little letters matter. So this is little b, little c, and little a. And can everybody see that we do have a side setup? All sides are given. I don't know any angles. Which angle would you like to find first? You want to find them in alphabetical order? You want to find them in order from biggest to smallest, smallest to biggest? Reverse alphabetical order? You got a lot of choices, okay? All right, so which angle you want to find first? Okay, good. We'll find C first. And here's the formula we're going to be plugging into to find angle C. Cosine of C equals. All right, here we go. That's going to be A squared plus B squared minus C squared. 2 times A times B. And don't forget to use parentheses if you need to. Parentheses around the top and the bottom. And I'm going to need that worked out to a decimal. Does anybody have that worked out to a decimal yet? I'm ready.
Negative 0.60.
Negative 0.0642.
No, negative 0.6.
Not 0.6.
So negative
That's 6 and 0 needs a flip.
0 point,
6, 0.
like that, negative 0.604.
604. 6042.
Negative point. That one, okay, 6042. And then what is the inverse cosine of that? And I would like it to the nearest whole number. What is that rounded to the nearest whole number? 127. 127. Now there is a reason that I wanted to find angle C first. And what I'm about to say is important. Are you listening? If you're going to use the law of sines to find your angles, the law of sines will not find an obtuse angle correctly. So if the angle you're looking for is obtuse and you're trying to use the law of sines, it's not going to give you the right answer. So how many obtuse angles can there be in a triangle? Only one. Right, like the movie Highlander, there can be only one, obtuse. And if I find it first, then I can go and use the law of sines without fear. You understand what I'm saying? Because I know that these other two angles have to be acute. And the law of sines will do that just fine. But if you want to keep using the law of cosines, we can do that too. So I still have to find angle A and angle B. Do you want to use the law of sines or the law of cosines? Law of sines? Is that what I heard? Okay. All right, so to set that up, we're going to say sine 127 over what side? 9. Sine of, and now you have to make a choice. You want to do A over 4. And then once you get that set up, we need to cross multiply and divide. And so that's going to be 9 sine of A, 4 sine 127. Divide both sides by 9. And that's going to be 0 point something. I have no idea what it is. 3549. And then we're going to have to do the inverse sine of that to the nearest whole number. And anybody can give me the answer. I'll take it from anybody. What do you got?
I got 20 point. You said to the nearest whole number?
Whole number.
21.
21. Yes.
I went using the law of cosines and got 20.
20 what? Degrees?
20 degrees, right?
Oh, for angle A, which is close.
So is that okay?
Yes.
Okay.
And that means on the next test, I'm going to have some flexibility. Yeah. It's going to depend. It's going to depend on how many decimal places I want you to take it to. Yeah. So you said you used the law of cosines and you got 20 degrees instead of 21. And I can't imagine why. Well, no, wait a second. This 127 is rounded.
Yes.
The 127 is approximate. So when I throw that in, that makes this answer approximate even more. So
So the 20 is also approximate. The calculators are 19.948 than some other.
okay, but you understand using the law of cosines doesn't involve the approximated angle here. So your answer is probably closer to the correct value because you didn't use an approximated value. So either way, 20, 21, little flexibility. And then what is angle B based on the other two angles? 32? Or Jasmine, you're going to get 33. 33. One, two, three. Did I find all the missing pieces? I'm done. I found all the missing pieces. All right, so it looks like I've got about 3 more examples to work through and then we're done. About 3 more to go. Let's see, do I need to go to a new page? Might as well. Let's go to a new page. Add a page. Can I drag that up there? Bam. Oh, yeah. All right, number 17. And for this problem, they don't give us a picture. They just list the angles and sides and which ones are given. And it turns out that you actually don't need a picture to know how to set these up. Picture's not necessary. When I taught the law of sines, do you remember I said that you have to have 2 of the same letter for the law of sines to work? So is the law of sines going to be able to work here? No, because I have big C, but I don't have little c. And I don't have big A or B. So I don't have 2 of the same letter. So the law of sines is useless to start with. But I do have an angle and 2 sides. Is this side angle side? And we know that for sure because it's A, B, and C. 3 different letters, side angle side. Now you have to decide which of the 3 formulas we're going to use. Yeah, and we're going to use the C squared formula because we're looking for little c. Everybody see? Okay, here we go. 3 squared plus 4 squared minus 2 times 3 times 4 cosine of 40 degrees. And that's plugging into the formula. And then we're going to have to take the square root of both sides. And as soon as somebody gets that worked out, I'd like to know what the answer is. Yes, I'm at your mercy. I didn't bring my calculator. I have to wait for you.
I think it's 2, wait, how many do you want?
To the nearest 10th. Nearest 10th.
2.6.
2.6?
Yeah.
2.6? Everybody getting that? Everybody, if you're not getting that answer, let me know, and I'll verbally harass you. Okay, so now I have a question for you. Now, if I want to, can I go back to using the law of sines? Yeah, because now I have 2 of the same letter, And I can use law of sines, but do you want to? Or would you rather use law of cosines? Which do you prefer? Law of sines? Okay, so be it. Oh, but time out though. Time out. This angle C is acute. That means one of these could be obtuse. So I can't use the law of sines to find the one that is obtuse if it's obtuse. So which angle would be obtuse? Do y'all see that B has the biggest side? So he has to be the biggest angle. So I can use the law of sines as long as I use it to find angle A. Let's do that. Because y'all seem to be hell-bent on using the law of sines. So I'm going to let you, but I'm going to put training wheels on and make sure you don't crash. Right? We're not going to find angle B first. We're going to find angle A first. So we're going to say sine of 40 over 2.6. Sine of A over 3. And then we're going to cross multiply and divide. 2.6 sine A, 3 sine 40. Divide both sides by 2.6. And that's going to be 0 point something. 7417. 7417. And then what is the inverse sine of that? So 48 rounded. So 48 rounded. And now we can find angle B the easy way. And if it's obtuse, that's okay. We'll get it right. But it's not obtuse, is it? Or is it obtuse? Barely? What is it, 92? Oh, that's obtuse. He still needs to go on a diet. He's got 2 pounds to lose. And then he'll be right. Get it?
So, if we find all of our side values, can we automatically figure out which angle is going to be obtuse based off the side value?
Exactly.
So we knew that once we got 2.6 for little c, we knew that big B was going to be the obtuse angle because B was the largest side.
Okay, Matthew, we knew that angle B could be obtuse. Not a guarantee. But once you find this side and you know all 3 sides, you can identify the angle that may be obtuse and then avoid it for last. Did y'all hear? That was good. Save the big one for last.
So that's why we did A.
Right. Now, if you're doing the law of cosines, though, it won't matter. The law of cosines will find an obtuse angle. So really, if you wanted to play it safe, I'd use the law of cosines to find everything. But if if you're hell-bent on using the law of sines, just make sure you save that biggest one. I didn't say it's guaranteed to be obtuse, did I? No, but you save the big one for last. I've got another problem to do. Anybody have any questions on number 17? Okay, next problem. Number 25. BC. ABC. 29, 21. There you go. Again, we're not given a picture. We're just given a list of information. And is the law of sines an option? because I don't have an angle in the side across from it, right? So I have to use law of cosines. It is a side, side, side. I heard somebody say that. Does it matter which angle I find first? No. Remember, law of cosines will find an obtuse angle if it's obtuse. So which one do you want to find first? It doesn't matter to me. B. Now, did y'all also notice that angle B could be obtuse? Because he's got the biggest side. Okay, here we go. So, plugging into the formula for cosine of B, that's going to be 20 squared plus 21 squared minus 29 squared. 2 times 20 times 21. And then make sure that you use parentheses top and bottom if you need to. And as soon as somebody gets that calculated correctly, I'd like to have it. Anybody got it? What is it? 0. Anybody get 0? No kidding? Okay, fine. Hang on a second. Okay, well, fine. What is the inverse cosine of 0? What kind of triangle is this? That's a right triangle. And that means if I want to, I can use SOHCAHTOA. See how excited I got? SOHCAHTOA. We don't have to use the law of sines or cosines. We can use SOHCAHTOA. Oh, yeah, boy. Okay, but I think we're going to use law of sines because y'all seem to like that. All right, so we're going to say sine 90 over what? 29 equals sine A over 20. Everybody okay with that setup? And then we're going to cross multiply and divide. 29 sine A, 20 sine 90. Divide both sides by 29. Zero point what? 897? 897. And what is the inverse sign of 0.897? To the nearest whole number. I heard two different numbers.
I got 44.
44 or 46? 46.
For your point 897, I got 0.6897.
Oh, 0.6897.
Yeah.
Okay, well, I wrote it down wrong then. .6897. Why is that so far off the screen? All right, here we go. Now, what is the inverse sign of 0.6897? 44 to the nearest whole number? And I've got one more angle to find. think it's going to be 46. Because don't they all have to add up to make 180? And we're done. All three angles found. Now, if you're keeping score with what we've done so far, I've done 2 examples of side angle side setup, and I've done 2 examples of side 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 setup. Okay, so we're kind of even at this point. And for the tiebreaker, we're going to do a word problem. I know how much you guys love the word problems. Let's see, we need a good word problem. Let's try number 57. It's baseball. Yeah. Wrigley Field, home of the Chicago Cubs. It says the distance from home plate to the fence in dead center field is 400 feet. Let's draw a picture. Home plate. Dead center field. Home plate to dead center field. The distance from home plate to the fence in dead center field is 400 feet. And it says, how far is it from the fence in dead center field to third base? X. 400. Yes?
That triangle is supposed to be your home base.
What triangle?
That big one? I mean, is that like diamond?
Oh, this?
Yeah, that's supposed to be your home plate?
Oh, this is home plate.
Okay, that's
This is second base.
That's,
So first base, second base, third base, home. And if you go straight from home plate through second base all the way out to the fence, that's dead center field. Now you're going to have to know some more information. This is not enough information. You're going to have to know how far it is from one base to the next. Do y'all know how far it is from one base to the next in a baseball diamond? 90 feet. And did y'all know that a baseball diamond is in the shape of a square? So that means that all the angles are 90. So this one must be 45, because this line cutting through out to dead center field is going to cut that angle in half. So if this was 90, that's now 45. And now can y'all see that we have a side angle side? Can y'all see that? Side angle side. And we can find the side across from that angle. So here's how that's going to set up. Using our side angle side formulas. That's going to be 90 squared plus 400 squared minus 2 times 90 times 400 cosine of 45. And does anybody have any questions at this point? Yes, you can. Yes. In fact, you're going to have to eventually. But if you want to do it at the beginning and do that as one calculation with the square root button, it'll work. I figured there would be at least one question about setting that up.
I want to know which one we use, which formula specifically we use.
Because there's 3 of them, right? Okay. So if you go back to your 3 formulas, you're going to notice that every one of them has the same setup, basically. It's, look, it's side squared plus side squared, and that has to be your two sides. Doesn't matter what order. It could have been 400 squared plus 90 squared, minus 2 times, there's your two sides again, doesn't matter what order, and then the angle between them. So they're all basically the same formula.
Okay, so because we're not labeling them A, B, and C, we can use that pattern instead of that.
Exactly. And the key word there is pattern. You can use that pattern. The fact that it's going to be the two sides repeated and then the angle between them. And did anybody get an answer? Go ahead.
I have another question. It gave you 90, right? Like in your word problem?
It did. They actually gave a picture in the book and it shows these are 90s. Okay, anybody got an answer yet?
I got an answer. I got 342.32 or 33.
So let's say 342.3.
Yeah.
And what are the units?
Feet.
Feet. And so now we know if the outfielder, the center fielder catches the ball at the wall and he has to throw to third, we know how far he has to throw. And can he throw that far in one throw without it bouncing, or is we going to need a relay? Can you throw a ball 342 feet?
I'm sure they can.
Y'all know that's more than a football field, right? Okay, I don't know for sure. That's not part of the problem. Figuring out if it's feasible or not. Okay, I got another problem I'd like to do, and I've got time. Let me see if I can find it. I don't see the problem I'm looking for. Okay, I'm just going to make it up then. All right, so we're going to call this my problem. What? Are we good? Okay, so let's say we've got 550 feet. This is going to be 390 feet. Why did I put degrees? Feet. And $40 degrees. And this is like a problem where you're a real estate agent and you've got this triangular piece of land and you can actually access these two sides of your piece of land, but for whatever reason you can't access this side. Maybe there's a lot of brush or a fire, I don't know, but you can't get to this side. But you know these two sides and you can measure the angle between. Can I find the length of that other side? So is this a side, or side angle side? Okay. And I'm going to say that that's X. If you wanted to label the angles A, B, and C, you can do that. But I'm going to just say X. And does it matter which side I pick first? No. So what do you want to say first? 390 squared plus 550 squared minus 2 times 390 times 550 cosine of 40 degrees. And then if you want to take the square root of both sides right now, you can. And I can't wait to get the length of that third side. And I'd like that to the nearest tenth of a foot, if that's okay. Nearest tenth. I'm ready. Not everybody at once. 0.9? 990 or 9? Okay, yeah, I don't care. 9. And the units are feet. And now I can advertise my piece of land in the paper because now I can give the dimensions of all three sides. Right? Y'all know that they do that, right, in real estate? So that's where this is useful, real estate. All right, and that's going to do it for this evening.